Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great event on tap, but before we get started, I do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. We'll be sending out an email post-event that contains a link that will take you right to the webinar. And we are taking questions from the audience. So if at any time during the presentation you have a question for our panelists, don't wait, just use your GoToWebinar control panel and submit your question. And then we'll take a few minutes near the end of the webinar and we'll go through those audience questions. Okay, with that, we'll go ahead and jump right on into today's webinar. Learn how sorry, tripping over my tongue here. Learn how Sudokrew used InfluxDB to monitor the health of their IoT systems. So our speakers today are members of Sudokrew. We have Jason Sewell, who's solutions architect and co-founder of Sudokrew, and Tony Gaskell, who is developer tech lead at Sudokrew. Welcome, gentlemen. Thank you so much for joining me today. I appreciate it.
Thank you for having us.
Great, great. Well, Jason, I know you're going to be driving this, so I'm going to turn it right over to you to let you do your thing.
Awesome. Thank you so much. Yeah, thank you again to DevOps.com for having us, and we're excited to talk a little bit about some of the work we've done. So yeah, a little bit about who we are, just to start off. We are a consultancy. We're located in Honolulu, Hawaii, and we do a lot of custom solutions, engagement work with clients, web applications, cloud architecture, mobile solutions, data engineering. We're primarily a full stack JavaScript shop at this point, although we do dabble in some other areas. But JavaScript, React, Node is kind of our core competencies on the front end and back end, and then we like to play with data. And so we've kind of had experience in many different data models and pipelines and things like that. And with kind of the focus of this webinar today is more of our entry and some of the lessons that we found in terms of getting into handling time series data and time series databases. We also have we are an engineering shop and we pride ourselves on that, but we also have a passion for UX and UI. So we like to not only have nice functional software, but have it look, have beautiful experiences, as well as we like to say. So a little bit about me. We'll do just quick intros for myself and Tony, and then we'll get into it. So my name is Jason Sewell. I am the solutions architect and co-founder of Sudokrew. Most of my background has kind of been around the web and making machines talk to machines. So I've done a lot of kind of interface integration, systems integrations, full stack web application development, API development, things like that. My primary role anymore is really solutions architecture and DevOps, and kind of all the time trying to get better, or more robust DevSecOps kind of pipelines integrated into our workflows, and that's kind of what makes up my time today. And with that, I'll let Tony introduce himself.
Yeah. Hi, I'm Tony. I'm a tech lead here at Sudokrew. My background is primarily in web technologies, a lot of front end, back end, and I guess now dabbling more into like distributed systems and IoT devices. But I think for this project, we've been working on this one for a while, and I think we're pretty proud with what we have and where it's going to go in the future. And I'm excited to talk about that.
Cool. All right. Thank you, Tony. So with that, we'll get into it. So a lot of the work we've done here at Sudokrew, we say that we like to build software that matters. We are in Hawaii. It's one of the, at least in the U.S., we have the most had the most. California just jumped on, but had the most aggressive clean energy legislature that had been passed in terms of getting to 100% renewables. So kind of with, you know, the location that we were in, we have worked with a lot of solar and clean energy companies, and that's kind of how we've gotten into this IoT space and data engineering and things like that. So we've worked with some Blue Planet Energy, Revolution, Island Pulse, which actually was kind of a tactical legislation tool that helped pass that legislation. We efficiency, and we also have worked with Elemental Accelerator, which is a accelerator for kind of environmentally friendly startups. The project we're going to specifically talk about today is it really revolves more around battery monitoring. So one of the clients that we've worked with has a solution where they have an on-site battery storage, and they need to monitor things like state of charge, production, consumption, general uptime and availability, and be able to kind of the system kind of builds off of that, and there's a lot of components that go into that, but that's kind of the heart of the system, is that for these solar battery storage devices, especially for some of these off-grid homes, they really need to know the heartbeat of their household, which is these batteries. So this is kind of at the core of what the project has been and kind of what led us down this road. Some of the larger system that's gone into this it really is a much larger business outside of the battery. There's a lot of verticals that go into that. We have the administrators of the company that kind of manage all functions across all verticals. They, you know, add devices, add dealers, add project owners, assign things, you know, standard administration kind of stuff. We have dealers that are out there kind of, you know, working with the customers on sales and having some of those, the CRM needs and managing that sales pipeline. And then we have the project owner, who is ultimately the end customer, who is interested in some of the other interfaces that we'll go over in terms of actually monitoring the system itself and that on-premise device capability. So that's kind of the larger picture. We'll really just be focusing on data for the most part today, but that is the larger system that we've been working on. So not going to talk too much about this slide, but admins do have the ability to add users and devices to the platform. This is one of, I think, 6 different portals into the system, but I don't think it's super relevant to kind of what we're talking about today, but just to give you an idea of, you know, users being commissioned devices, and that's ultimately what we are monitoring, and the frequency and volume of data that we're dealing with. For ultimately the homeowner, this does have a mobile monitoring solution as well. And this kind of led to some of our challenges around data. Is obviously there's for anybody that's kind of been involved with data at the user experience level, you know, you want data to be meaningful. You would like it to ultimately be actionable, and again, we like to have, you know, fun with the design side of stuff and actually try to make it a really nice experience. So this is kind of one of the end goals, but the primary end goal of the reasons that we had to work with this data and seek kind of new solutions based on kind of where we had come from before. So you'll see in the first slide, the user sees how much time they have, the state of charge, so the total state of charge of the battery, how much time that they have until the battery were to be drained. So if you see 2 hours on that, that can be a little bit alarming. And again, when that's the heartbeat of your household, you want to know that as soon as possible. And then just more kind of usage and production-based data, production and consumption. You know, things are always kind of going up and down when you're revolving around the cycles of the sun, and a couple more granular views. And then there is some filtering here too in terms of the time periods that you're viewing data, which is again is a data challenge. If you're viewing for 60 minutes, it's one thing. If you want to show for 3 months when you're reporting data at second intervals, that can be a challenge. So kind of give you a little bit of context of where we started was that this is kind of the data flow of the energy the battery data, not the full system. But this is what we started with, is that our devices send an HTML payload to an API endpoint. We've used message queues for since the beginning. We'll see in future slides kind of where we took it from there. But essentially, we had an endpoint all devices are reporting data to. We then drop that on a queue so that we can keep that endpoint really highly transactional and kind of save as much resources. So we are using Node.js so that the event loop and really dropping messages onto a queue is a very performant way to kind of manage that system entry point for data. And then from that queue, we have a worker that picks messages off the queue. And at the time, we were working with a proprietary database. And I actually realized that I'm supposed to be letting Tony talk now. So I'm going to turn it over to Tony. Sorry, Tony, take it away.
No problem. I thought you were doing really well. I think, like what Jason was saying, before we moved to Influx, we were using a database that we didn't really have any access to, but we were able to kind of monitor the box that it was running and like the traffic, and we were able to check out that stuff. But we really didn't have much control over the system, especially like if something happened at the process level that we didn't have any visibility into. And I think that was one of the reasons that led us to really overhaul our database solution. And I think if we go to the next slide, we can describe or talk about that a little bit more. Some issues that we ran into were definitely related to like scalability issues. The system that we were on was a single instance. It scaled by just buying more storage, and we started to move into a place where we couldn't really buy more, at least. Yeah, I guess that's the best way to put it. We were running into instances where we were running out of space, and we're kind of in a situation where taking a system like this offline just to upgrade it, there's issues with outages, and especially with streaming data, we don't want to miss any of that. So it was a little bit trickier to work with. We also had only one instance, and our only solution really was to store backups and snapshots of that one. And if the instance were to go down, we'd have to roll back. And again, we're worried about that data loss. In other instances too, on the application side, we were running into, there were needs from the applications. We had slides earlier that showed the mobile application that would run on iPhones, but we also have a desktop portal that allows the user to kind of download more data, view that data, and the differences between those two applications was the amount of data points that they were pulling down. And so we did run into like some issues with running the queries, trying to optimize our queries on the mobile device versus the desktop, trying to aggregate our data into smaller, I guess less amounts of data, so that the mobile device wouldn't run slowly. Because it was an interactive application, we wanted to make sure that the users could use it without experiencing any slowdowns. Yeah, and I guess on the other side too, because the data was proprietary, we really had no way to really expand it if our application needs changed. Like if we added more devices into the system, there wasn't a real good way for us to update the schemas that were in the database. So we were kind of in a situation where we didn't have as much flexibility as we wanted, especially when the system was growing and the needs started to change. We can go to the next slide. So this kind of like all of these issues that were building up kind of led us to search for a new solution. And that's where Influx came in. I think, actually we can go to the next slide. Just describing how that came about, some background. Like we're not database engineers at Sudokrew. We're more focused on the application side of things. And just doing time series data, that's kind of new, I think, especially for us. We had some experience with things like Elasticsearch, and kind of when we're looking around, you'd type in, what are the best time series databases out there? And Google would just kind of be like, oh, here's like the top 10, you'd see a bunch of blogs and other people talking about their experiences. And, from there we saw things like Elasticsearch, Prometheus, and Influx. And I think, we went into it kind of blind, and but at least this kind of gave us a way to, some names and things to check out. In the end, though, we did end up looking kind of at Influx and Prometheus, mainly because they addressed some issues that we were running into, like scalability. They both had clustering solutions. They both had HTTP APIs that we could query, which we're familiar with, and they both provided like query functions that allowed us to run aggregations over the data that we needed for our apps. And both of them were open source, which was kind of nice because that gave us the visibility into the system that we didn't previously have working with the black box system. The main, and I think one of the main deciding factors too for us was that Influx had a hosted solution, like an official one, and that was that gave us a peace of mind that we could rely on them. I mean, their support team has been really great for us, and that saves us a lot of time as developers who are just working on the applications, so that we can, if we're experiencing an issue, we can kind of reach out and know that someone can help us. We can go next slide. So before we actually, implemented it and went off of that, we did want to look and test the system, the Influx system, against our existing one. So we did use an open source tool called Bees with Machine Guns, which is essentially Apache Bench built with EC2, and it allowed us to kind of generate an environment or provision an environment that we could scale in order to make sure that this new system was going to be able to handle the requests that we were currently experiencing or what we were actually planning on running into in the future. So this was kind of a way we essentially just used this tool to essentially DDoS our systems. We created like clones of those environments just to kind of test it. But in the end, like Influx was much better than our current system, especially with the ability to scale and handle queries. These are some of the results that we received, especially when a lot of the performance gains were when we're querying like the live data that was coming in. And in the end, I think even though well, in the end, it was faster at every point, and could handle more requests. We did run more queries with like higher requests or stress tests, but our other system wasn't even able to handle those. There were a lot of drop packets, and that was just a way that we got some insight into the system. We can go next. Some other issues that we ran into were on the schema side of things. The data that we receive from the devices that we're monitoring come in an XML format, and we had to figure out a way to kind of translate that into something that Influx could use. And a lot of that came down to really reading a lot of the docs that were provided. Their documentation is great, a lot of getting started, but there's key concepts that we needed to be familiar with, especially with data series, versus what we were currently using was, or before we were using Influx, it was almost like I guess a SQL table sort of, in the sense that we kind of stored all of our data in chunks. Like one payload was going to have a bunch of registers associated with that. But moving over to a time series database, we had to make sure that we would separate those into their own data streams. So even though we get one payload from our devices, that could come out to be 30 data streams. And it's split up that just to write the queries needed to get that data was a challenge that we had to overcome. Yeah, we can go to the next slide. Some questions that we had, or I guess that we wish we had known, I guess, going into this, was, how much data are we expecting to get? Because, what you build now isn't necessarily what your system's going to be in the future. We did at the beginning add a data queue, which, that could have, if we didn't have that data queue, I think we would have been in a really bad situation. But just having one data queue gave us a point in the system that we could kind of scale it up if we wanted to, if more devices were added into the system. And then another thing that we needed to figure out was how long do we want to hold on to this data? And that kind of goes into a bunch of different places, like, do you care, I guess, about the data that comes into the system, that raw data, or do you only care about the data after it's been processed? How long do you want to hold on to that? If you're doing time series data and you're taking data every second, of the day, that comes out to be a lot of data. Will your system be able to store all of that? Do you have a solution that allows it to scale up if you need to? And again, related to the previous slide is like, what format does that need to be in? The data that you receive is not necessarily going to be the format it's going to be stored in. We can go to the next slide. So those kind of issues that we ran into and the questions that we asked ourselves kind of evolved. Our system evolved over time. The single data queue that was processing all of our everything split into 4. I guess you can see that in the middle. We had a data exchange queue which would split that data off. We could run our backups and store those in S3. We could store like the XML payloads that we're receiving, and over time we could store that in Amazon Glacier, just because that's really good for long storage, and you're not going to be accessing that data very often unless maybe you need to run some sort of backup or replay some actions that executed in the system. Another one is that we created a monitoring queue to do health checks in our system. This was really important to us because if you're ever running live data and for some reason a device goes offline or there's a connectivity issue anywhere in your system, you need the visibility into that system to be able to say, hey, let's trigger an action off of that. In our case, we don't have any control over the devices that are pushing data to our servers. And if we experience, I guess, a period of time where the devices are no longer sending data and we're expecting that, we can throw a message onto a queue and kind of make sure like, oh, let's run a backfill script that can query our devices. I think we're fortunate in our case to have the ability to actually query devices. But I think having the ability to trigger those actions is important, and that should be a responsibility of your system that you're building. And so I think that just having that one design consideration in the beginning, just to have one data queue, what allowed us to kind of expand this and scale our system into something that could handle these events that we didn't even foresee when we first started. Yeah, but I guess that's all that I have to talk about the system. But I have, well, does anyone have, I guess, questions or anything like that?
Okay, let me see. Looks like we do have, we have one question, and it's simply tagging.
Are you talking about tagging for the data that's coming into our systems?
It says influx tags are kind of unique, so that's
yeah. So if we go back to the slide with the XML data, Jason. So I think that is true. Tagging was something that was a little bit different, coming from like a SQL side. In the end, there's two types of tags that you want. There's the ones that you can that are indexed and others that are not indexed. In our case, we decided that the ones that we would want to index by would be like the units or the register names, because on our front end application, we want to be able to run like aggregation queries against those data points and be able to query things like what is the state of charge of a battery versus things like units. Those didn't matter as much to us. So that was kind of like, it really depends too on what your data looks like. But I think if you want to, you have to look at like what your application is going to use, what kind of queries are you going to be running often, and the ones that that you're going to be filtering by, you want to make sure that you're indexing by that.
All right, great. Yeah, we've actually gotten a lot of questions in here. So the next question is, how is the monitoring queue and data queue different?
Sure. So in our case, we have the data queue is really kind of a simple queue, I guess you could say. There's not much logic that's going on. When we get the initial data that comes into the data exchange, we split that off into two messages. And that way, just in case there's an issue running the health check or backing up that data, we don't want those things to interfere with each other. So that's why we've just delegated it out into two different spaces or two different queues.
Yeah, so we kind of have a concept of multiple jobs require multiple workers instead of just as humans, as opposed to making one person do all the work. And so really we wanted a kind of unobstructed flow of data to the database, and so that's what you see the data queue here. As Tony mentioned, it's fairly lightweight. And really its sole purpose is to make sure that data payloads get to the database with very little risk. And so that's kind of, for us, why we prefer a microservice architecture in systems like this, is that we kind of like to make single jobs as simple as possible, and leading to as little failure scenarios as we possibly can within that particular data flow. So the data queue was really just get the data to the database, because the rest of the system really relies upon it. The monitoring queue really was more so the fact is that we deal with hardware devices, IoT devices, that we do not have control over necessarily. We don't always have visibility in the nature of the business that this is. That some homes are on satellite internet, so their internet can be spotty sometimes and go down. The Wi-Fi at the house can go down. There's a lot of data failures that can happen that we don't have any control over at the cloud level, because we're just expecting devices to report to us and kind of be stewards of that data and propagate it throughout the system. So the monitoring queue was, we actually have kind of monitoring happening in two senses. Is that every payload that comes in goes to the database, but it also goes to the monitoring queue, to which we're actually storing in Redis kind of state of communication, so that we know when the last time a device spoke to us without having to go query the database, right? So we don't, a time series database probably, number one, isn't the best probably database for doing polling, and number two, any database really shouldn't, if possible, that's a lot of extra load if we're going to be querying our database consistently, just to know if devices had reported. That's taking a lot of resources away from potentially consuming that data, and all of the read operations are going to happen against that database. So what we wanted to do was really break that out, is that let's use a very simple data cache to know, when devices had spoken to us recently. And if a device sent a message and we had not heard from that device in a certain amount of time, that would trigger a condition here that a backfill is needed. And so this was actually one of the problems too that we had with the proprietary database versus Influx, and where we really got a lot of gains on Influx in problems that we just could not solve with the prior solution, was that we can trigger a backfill, which then goes and, as Tony mentioned, can query the devices to resend data for certain intervals of time. And so this allowed us to really kind of be somewhat dumb about backfilling data, is we didn't really have to go get the data and then kind of do this. And even if we were dealing with a relational database, we didn't have to kind of like figure out where the gaps were and patch them, which was, it just is a crazy amount of programming, and really, really highly error prone, and just a lot of work, right? And so what we had the ability to do here was know kind of where that gap was, and request that data to be sent again, and it goes through the same workflow as any other data. So we really don't get into these conditional scenarios of like, if it's a backfill, do this, otherwise if it's normal behavior, do this. And those are just, where bugs and failures happen in systems all the time. So we could actually re-trigger through our regular data flow. And then this is where Influx was really good, was all we had to do was send that data back to the database, and Influx handled that that replay of data very, very gracefully, and we didn't have to identify the gaps by kind of submitting duplicate data. There's no risk of kind of duplicate data. There's no side effects of having the same payload written twice for that series of time. So that's kind of why we split them out like that. Again, is that this is kind of like, this is our crystal, or this is our happy path, right? And we don't ever want to mess up the happy path. But there are these other requirements on the system, even like this backup, is we want the raw data. So we want this raw XML for, we never know when we're going to have to maybe migrate to, to Redshift or something that is going to have needs for more big data. And again, we can't pull that out of a time series database in the way that we'd want to. And so we handle that backup in the same way. But again, it's to kind of optimize the flow of data, and that's really kind of what this is all about, is how do you have reliable, consistent, kind of concurrent operations handling these different use cases that don't screw each other up, right? We don't have a problem in our backfill that's gonna cause failure in our happy path of data entry.
All right, great. So then the next question is, did the queue allow for an elastic flow of data to account for the backflow?
Not sure what elastic flow means in that sense.
I mean, if the question is talking about, the influx of data that would be coming in, that would be triggered from the backfill, in addition to the currently running, I guess, messages that are coming in from the devices, the live streaming data. On our side, the data queues do allow us to, I guess, handle that surge, I guess. Because we can spin up more queues, like duplicate any of the queues to account for any bottlenecks or influxes of traffic that's coming into our system. And I do really like that portion about like the systems design because it is very scalable in that sense. And you can kind of switch it up, whether like at any point in the system, whether there's many backfills that are being triggered or more devices are just being put online. I do think the message queues have really helped us there.
Yeah, I see the same person added that they were talking about the depth of the queue and then never losing data, and yeah, 100%. That's why we've gone with the queues. These all run as Docker containers, and so we have the ability to scale up the consumers of that data should the queue really start getting, if we have 100 devices on the system and all of a sudden they go have an installation up to 1,000. That's the volume of that data is pretty substantial when you're dealing with per second time series tracking. So yes, the queues were a means to never lose data, even if one of these processes gets fails for any reason, gets overwhelmed. The message queues actually write to disk, even in the event of a system restart, which we've never had, but it's one of the reasons we use queues is because that's written to disk. You don't have data in memory. Your data is actually at rest as you're processing it, and so you don't lose data in transit should any failure happen anywhere in here, and it's easy to monitor these. And then actually what we're in the next phase of this, what we're about to go to, is we're migrating a lot of this into AWS services, and we'll be using their simple queue service, which again, just kind of we had the slide that open source for the win kind of thing, and the fact that we can't do managed services all the time, or the more help we can get on managing load and scalability, the better. And so what we're doing is actually migrating to Amazon's queue service, so that again, should that scale be needed, they have the capacity and the systems that have been tested to handle that gracefully and still achieve our objectives of never losing data, and the depth of their queues is scales automatically to load, so we can again focus on the application, the consumer, and the experience, and not be just tweaking and fine tuning RabbitMQs all day, which I will say RabbitMQ has been fantastic. Like, we have had zero problems with it, and I think it's a amazing technology, but just where the overall system is as a whole right now, that's kind of it gets a little bit of favor in that point. But Rabbit has been absolutely great.
All right, great. Just a reminder to the audience, there's plenty of time left. If you have a question for Jason or for Tony, just go ahead and use your GoToWebinar control panel and submit your questions. The next question, what is the role of the Express Server Message Producer, that little cube?
For us, or in our situation, the devices that are sending data require an HTTP endpoint that can receive that. So on our side, we had to spin up some sort of Express server that has routing. There's an endpoint that devices can hit, with like credentials so that we know what device is sending the data. But mainly for us, that's just accepting the HTTP requests and then dropping that data onto a queue for later processing.
All right, great. The next question, which queue had a better ability to handle back pressure?
I would say probably the data exchange one, just because that one is probably being hit the most. Most of the traffic is going through that. So in our cases, like I don't think we've really ran into a situation where the queues have been an issue. But if there were any point, I would say that one. I don't know, Jason might have a better or more insight into that.
No, like I said, I mean, the queues, message queues are something we've used for a long time. And we've never had any ability with any or any problems with any of the queues. They've all been able to, so the RabbitMQ queues are for anybody that doesn't know, is built on Erlang. So they're very good at handling those kind of microprocesses. So we've never had any problem with that. With the infrastructure that we had, and the fact that these consumers were repeatable containers that could easily be bound to these queues, it wasn't. So if any of them did have back pressure, it would really just be a matter of scaling up the consumers. And again, part of kind of what we're doing in migrating to AWS off of, when we started this project, it was kind of like startup mode for the company. And now they're really kind of cranking, and so it's kind of working towards more stability. And so putting this also on the cloud in AWS gives us the ability to kind of set up auto scaling configurations easily for these consumers. So even if we were to stay on Rabbit queues, the number of messages that are going into all three of these, the data backup and monitoring, are all the same. So they all, I think, take currently about 6 million messages a month. So we have about 20 million, I think, payloads going through all of them. And like I said, none of the queues have ever had any problem. It's just a matter, if they start to fill up, being able to detect, monitor that effectively, and react to it and scale up and scale down as needed. I think for this system, primarily, we're only ever going to scale up because of the consistency of reporting. So it's not likely that we'll have, peak, times of peak traffic. It should really kind of go up linearly as the system grows.
Okay, great. Next question. It's a little broken English, so hopefully you guys will be able to understand it. Does it mean XML from device is a combination of monitoring as well as measuring data, and data API engine process the same?
For us, the data that's coming in, it is the data that's being sent is really just the live data that we're measuring. So it's measured values. From there, there are some pieces that we can use for monitoring, such as the timestamp. I think that's probably one of the only things that we're using currently. But all the data that we're receiving right now, we're treating that as measured data. I think that answers the question.
Okay. All right, great. The next question, you show a line of XML data between backfill, runner, consumer, and data API endpoint, but we don't see a direction. So which direction is the data actually going?
Between backfill runner.
And data
Oh,
API endpoint.
oh, I see. There's this dual arrow. So yeah, what's actually happening is the backfill is submitting. So the IoT devices actually have the ability. They have query ability um, to push a new payload. And so what this is doing is actually submitting an HTTP request to the device, and then the device then reports it back through the normal data flow as it would. So this is an error right here. This is not a bidirectional data flow. Or wait, I'm sorry, I take that back. This does go to the device, gets that payload, and then submits it through the regular data flow. So this is kind of a broker in the sense that it picks up a request to backfill data from the queue when it passes this condition, and then it goes and gets the data, and then once it gets that data, again, instead of like setting up a flow here where it goes, we have another path of getting data to the database. Really, we wanted to just handle, be just kind of more of a proxy and really just get the data and pass it back through the regular data flow. And then we never have to kind of try to troubleshoot or debug, multiple paths into the database.
Okay, so that line that goes between the backfill runner consumer with the XML tag back up to the data API endpoint up at the top. So there should be an up arrow.
Yeah. So this, there is like two arrows right here.
Yeah. Okay.
If you could see it. So this, so like I said, this is a HTTP GET request. Data comes back. It takes that XML packet and sends it back to the data.
Gotcha. Okay. All right. Great. Okay. God, we've gotten some great questions in so far. Okay. Next one. Silly question. It's not a silly question. There's no such thing as silly questions. How do you guys tackle false alarm or data due to network issues?
That's kind of a little bit of that is kind of where a managed process comes into play at this point, is that we, a lot of, again, why we went with Influx Cloud as a solution, why we're kind of leveraging some of these AWS is managed services. Again, kind of like Tony said, we're not necessarily database engineers. At the same time, we do a lot of DevOps. We are a small team though, and the more that we can rely on really great engineers to kind of monitor systems, the more so that we do that. So, but we still do carry some responsibilities. And so there's one of the things that we didn't actually talk about, but this Datadog element down here, we are relying on Datadog for monitoring. So this tells us about the backfill. But again, when you're doing monitoring, you have to monitor, especially in microservice architecture, you have to monitor a lot of different things, and failure over here doesn't necessarily mean that that messages aren't being received over here. So when we started out dealing with a lot of devices that had variable reporting due to connectivity and things like that, these reports from Datadog were actually pretty noisy. And so we kind of had to tune them down over time and kind of identify problematic devices. So I don't know that they were false alarms as much as it's kind of one of those things that over time, as a business working with technology, you get to know your systems a little bit more intimately. And so we've kind of reduced the noise and just have known that some of these locations just don't report well, and the business has been able to be aware of that and communicate that with the client and understand that that those challenges occur. So I would say that we and then if all of a sudden all devices start reporting failure, then we know something's wrong. But that happens almost never. I'd say that the only time that that's happened, we actually realized that it was a problem with internally to the system, but we found it out very quickly and very noisily. So monitoring is very, very helpful. And I thought I'd updated this slide yesterday, but these Datadog alerts actually go to a Slack channel that we're all on. So we know very quickly when those events happen.
All right. Great. Next question, is the data discrete or continuous? And if it's discrete, how is the data getting aggregated?
So in our case, the data is discrete. We don't have like a constant connection with all the devices that are running. So there are like regularly timed intervals that we're kind of expecting that data to come in. I'm sorry, that was the first part of the question. What was the second part of it?
If the data is discrete, how is, or sorry, if the data is discrete, then how is it getting aggregated?
Oh, sure. So on our side, that's actually a really great feature of Influx. We're leveraging continuous queries that are constantly running on our data series, I guess. Over time, like we just set it up once to kind of monitor each of the aggregations. So the raw data that comes in is coming in at second aggregations. And over time, like, after 5 minutes pass, we kind of have a continuous query that's constantly rolling up that data and throwing it into like a minutes data series. And we have another continuous query on top of that that kind of aggregates it by hour, and it kind of goes on from there, extrapolates out. So for us, Influx is handling most of that for us.
Okay. All right, great. Next question. How did you migrate over to InfluxDB? Did both systems run in parallel?
Yeah, so for us, yeah, when we were doing the benchmark tests, we had to kind of create another system that was running Influx. This was before we went with the hosted solution. So we just used a Docker container that was running an instance of Influx, spun that up, and we were able to kind of set up another queue that would then, instead of pushing it to the database that we're using, it would split that up and send the payload to both the one that we're running, the legacy system, and the Influx system. And at that point, we were able to monitor both of them, both of the databases, and make sure that they're both receiving the same data.
Yeah, that was actually a challenge. I mean, just in terms of kind of where some of the hard parts were, is that the reason we did that, the parallel, was really the main view for the consumer is a 30-day view. And so to capture data for 30 days kind of got us in that transition period. One of the challenges that we had was the devices have the ability to be queried farther back in time, but not necessarily the processing capacity to do that well. So we can technically, go query the device for as much as like a year or more worth of data. But the devices, again, these are IoT devices. These are not, workstations and servers. So it was we had a really hard time going and querying the devices and getting the data from them. And again, kind of when we talk about being on that proprietary database at the very beginning, and the fact that although we had data in the database, it was completely useless to us in terms of porting it over to another system. We didn't have the raw data, and that's how kind of this backup queue came into place. Was that you never know, kind of like Tony mentioned, you never know which direction the business or your systems are going to take you, or just technology in general. And so had we always had this raw payload in place, the migration would have been, especially with a lot of Amazon's tools around S3 for data ingestion and data streams, would have been much easier. So if you're looking at doing this, data's gold in the age we're in, right? So it's not necessarily the easiest or cheapest thing to always be storing, mass amounts of data, and that's why we have kind of that archival policy in place for Glacier. But not having that raw data as the system matures over time can prove to be very problematic.
Okay, we're about 6 minutes to the top of the hour, so I think we have time for maybe one more question, maybe two, we'll see. Next question, we've actually gotten a couple questions in regarding JSON versus XML. So here's one. When you're using, why are you using an XML format for data from the sensors? Since sterilizing and desterializing is resource consuming for XML as compared to JSON.
We don't have a choice. That's why. The devices were meant to send XML payloads. So internally, we actually do that conversion. And when it's in our domain, we obviously prefer JSON as well. So we actually do a conversion. And yes, it takes a little bit of resources, but again, having these kind of lightweight, distributed workers, it at least isolates it, but yeah, that's a design of the hardware.
Okay, all right, great. So I think we have time for one more question. Let's see. Why were you interested in a hosted solution? Why did you decide to go that way?
Yeah, like I said, we're a small team, and again, we're also a consultancy, so we are not, we're not the full-time employees, right? So and so, when you start getting, again, we get a lot of engineering kind of advantages of kind of, this microservice architecture, and the system flows very well. But when you're dealing with the complexity of systems like this, the operational overhead also kind of increases exponentially. So kind of where you're gaining advantages in architecture, you're adding overhead in operations a lot of times. And so we kind of need help. We don't have 100 engineers. We have a few, right? And so for our case, it made sense is that the more kind of help we can get in kind of that monthly managed services billing, and the economies of scale that Influx gets and Amazon gets by just having many people on a platform, it really brings down the operational overhead of maintaining the health of these really core points, right? I mean, the database is really core. That was the problem we had. We weren't on a managed services with a proprietary database, and the thing kept tipping over. We were running out of disk space. We didn't have migration, we had migration limitations. We had limitations of time and capacity to even if we know how to do a data migration or add capacity to a system, do we have the time, and is there budget? And so there's a lot of just kind of like business, time and money kind of considerations that went into that go beyond kind of like even our ability to do it if we don't have the time and resources to do it. And that's what they do well, right? Influx is really good at, we've had a really good experience with their cloud offering, and it went from us having kind of daily, panic attacks and monitoring issues and, continually like maintaining the health of the database to not worrying about it and focusing on the product and the user experience, and the business can focus on growth and not be worried that, as they get new customers, they're going to lose customers, that kind of stuff. So.
Okay. All right. Well, good answer. So we are about 2 minutes to the top of the hour. So I think that's pretty much all the time that we have for the question and answer period. If we did not get to your question, I apologize. And just know that that the folks at Influx and Sudokrew, if I pronounce that correctly, we'll get a copy of the questions. So hopefully somebody from the organization will be able to get in touch with you directly offline. Just another reminder for the audience that today's event has been recorded. So if you missed any or all of it, you will be receiving an email after the event that contains a link to the webinar that you can access on demand. The slides will also be available to you at that time. I would like to thank Jason and Tony both for joining me today. What a great presentation. The audience had a ton of questions, so I know they got a lot out of it, and I did too. So thanks a lot, guys. Appreciate it.
Awesome. Thank you. Yes. Thank you for your time, and thank you for having us. And yes, if anybody would like to talk more about energy apps and data needs and DevOps and stuff like that, please reach out to us. You can get in touch with us through our website at sudokrew.com or by email at hello@sudokrew.com. So
Perfect.
thank you.
All right.
Appreciate it.
Great. Well, thanks again, everybody. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thank you.